Hello students, Saira. Today's session is final and concluding part of chapter 3, playing with numbers. So let's solve a few remaining problems of exercise 3.7. So let's see what is the problem. Problem number 10. Find the LCM of the following numbers: 9 and 4, 12 and 5, 6 and 5 and 15 and 4. And what do we have to do? We have to find the LCM and observe a common property in the LCMs found. And we have to check, is the LCM the product of two given numbers in each case. So let's see how we solve it. First one is 9 and 4. So let's find the LCM of 9 and 4 by division method. For this we write 9 and 4 and start dividing by the lowest prime number, that is 2. 2 does not divide 9, so 9 will be written as such. 2 divides 4 and we get 2 here. Again we take 2 and 9 will be written as such, and 2 divides itself, we get 1. Next we take 3, the next prime number. 3 divides 9, we get 3 here, and 1 will be written as such. And we again take 3 and 3 divides itself, we get 1 here and 1. So what is the LCM of 9 and 4? It is 2 into 2 into 3 into 3, which is equal to 36. So LCM of 9 and 4 is 36. And if we observe carefully, the LCM is the product of 9 and 4, isn't it? 9 4 times is 36. And 9 and 4 are co-prime numbers since they have common factor 1. So in this case, what do we see? The LCM is the product of the two numbers which are co-primes. Now let's move on to the next one. 12 and 5. So we find the LCM of 12 and 5 by division method. We write 12 and 5 and start dividing by the lowest prime number 2. Since 12 we have which is divisible by 2, so we take 2. 2 divides 12, we get 6 here, and 5 will be written as such. Now 6 is divisible by 2, so again we take 2. 2 3s are 6 and 5 will be written as such. Now we move on to the next prime number 3. 3 divides itself, we get 1 here, and 5 will be written as such. Next we take 5 and 5 divides itself, we get 1. So what is the LCM of 12 and 5? It is 2 into 2 into 3 into 5, which is equal to 60. And here also, when we observe carefully, the LCM, which is 60, is the product of 12 and 5. 12 5 times is 60, isn't it? And here 12 and 5 are also co-prime numbers. So what can we conclude here? If we find the LCM of two co-prime numbers, the LCM is the product of the two numbers. Now let's move on to the next. So problem 11. Find the LCM of the following numbers in which one number is the factor of the other. So here we have to find the LCM of the numbers where one number is the factor of the other number, isn't it? Here we can see 5 is the factor of 20. Similarly, 6 is the factor of 18, and for other numbers also 12 is the factor of 48 and 9 is the factor of 45. So we have to find the LCM of these numbers and we have to observe a property in the LCMs obtained. So let's start solving this. We take A, 5 and 20. So let's find the LCM of 5 and 20 by division method. For this we write 5 and 20, and since 20 is divisible by 2, we take the lowest prime number 2 and we divide 20 and we get 10 here, and 5 will be written as such. Then again we can take 2 since 10 is divisible by 2. So 2 divides 10 5 times and 5 will be written as such. Next we take 5 and 5 divides itself, we get 1 here. So what is the LCM of 5 and 20? It is 2 into 2 into 5, which is equal to 20. So we can conclude that if the smaller number is the factor of the larger number, then LCM of the two numbers is equal to the larger number. Let's solve the other one and check this one. Is it true for that one also? Yes, here we have 12 and 48. 12 is the factor of 48. So let's find the LCM of 12 and 48 by division method. Let's write 12 and 48 and start dividing by the smallest prime number 2. 12 is divisible by 2, we get 6 here, and 48 which is divisible by 2, we get 24. Again we can take 2 and divide 6 and 24, so we get 3 here and 12. Next again we can take 2, 2 divides 12, we get 6 here and 3 is written as such. Again we take 2, since 6 is divisible by 2, so we get 3 here and this 3 will be written as such. Next we take 3 and 3 divides itself, we get 1. So what is the LCM of 12 and 48? It is 2 into 2 into 2 into 2 into 3, that is equal to 48. So here we can conclude that the smaller number 12 is a factor of the larger number, okay, and then the LCM of these two numbers will be the larger number. So from these two problems, by solving these two, we can understand that when one number is the factor of the other number, the larger number will be the LCM of the two numbers. Now children, this chapter number 3 has been a long chapter, and you have been learning various topics in this chapter. So let's have a revision of all the topics those you have learnt in this chapter. So let's first see what are factors and multiples. So a factor of a number is an exact divisor of that number. Alright, so if we take 4 and 2, so what is the factor of 4? 2 is the factor of 4, isn't it? So what will be the factors of 4? The factors of 4 will be 2, 1, 2 and the number itself, because these three will be dividing 4 exactly. So a factor of a number is an exact divisor of that number. And what is a multiple? Multiple of a number is obtained by multiplying it by the natural number, by another number. Okay. So if we take 4 and 5, then what is the multiple of 4 and 5? 20. Okay. And 4 and 5 both will be the factors of 20. Alright. Now what are prime and composite numbers? So you have learnt that the numbers other than 1 whose only factors are 1 and the number itself are called prime factors. Prime numbers. For example, the numbers 2, 3, 5, 7, 11, all these numbers, they have only 1 and the number itself as a factors. So they are called prime numbers. And what are composite numbers? The numbers which have more than 2 factors are called composite numbers. For example, the numbers like 4, 6, 8, 9, 10, all these numbers have more than 2 factors. Alright, so they are known as composite numbers. And 2 numbers having only 1 as the common factor are known as co-prime numbers. Now, 1 is neither a prime number nor a composite number. 1 is neither considered a prime number nor a composite. So this was about the prime and composite numbers, co-prime numbers, and about 1. Now children, you also learned divisibility rules in this chapter. So let's quickly revisit them. So what is the divisibility rule of 2? If the last digit of any number is 0, 2, 4, 6 or 8, that means if the last digit, the digit in one's place is 0 or any other even number, then the number is divisible by 2. And a number is divisible by 3 if the sum of the digits is divisible by 3. And a number is divisible by 4 if the last two digits is divisible by 4. The number formed by the last two digits is divisible by 4, then the number is divisible by 4. And a number is divisible by 5 if the last digit is 0 or 5. A number is divisible by 6 if the number is divisible by both 2 and 3. A number is divisible by 8 if the number formed by the last 3 digits is divisible by 8. And a number is divisible by 9 if the sum of the digits is divisible by 9. A number is divisible by 10 if the last digit is 0. And for 11 we have a special rule: subtract the last digit from the number formed by the remaining digits. If the number formed is divisible by 11, the original number is also divisible by 11. So, you learnt all these rules in detail while learning this topic in the chapter. Now, some general properties of divisibility. If a number is divisible by another number, then it is divisible by each of the factors of that number. Okay. Then 2, if a number is divisible by 2 co-prime numbers, then it is also divisible by their product. Then 3, the general divisibility rule: if two numbers are divisible by a number, then their sum is also divisible by that number. And 4, if two numbers are divisible by a number, then their difference is also divisible by that number. Now, you learnt to prime factorize the numbers in this chapter. So, how do we prime factorize the number? So, what is prime factorization? The process of expressing a number as a product of its prime factors is called prime factorization. And how do we prime factorize numbers? There are two methods, factor tree method and division method. We have learned this, isn't it? For example, we have here 9999, okay, which can be written as this is a factor tree method, which can be written as 9 into 1111, and 9 can be expressed as the product of its factors 3 and 3, and 1111 can be expressed as the product of two prime numbers 11 and 101. So, what is the prime factorization of 9999? It is 3 into 3 into 11 into 101. And again we will look at the division method. How do we prime factorize the numbers by division method? For this, we write this the number and start dividing by the lowest prime number which can divide it. Okay. So, here 9999 is divisible by 3. So, we start dividing it by 3. So, what do we get? We get 3333, and 3333 is again divisible by 3. So, what do we get? We get 1111, and 1111 is divisible by 11, and we get 101, and 101 is a prime number again. So, it divides itself and we get 1 here. So, in both the cases, in both the methods, whether it is factor tree method or division method, the prime factorization of 9999 will be 3 into 3 into 11 into 101. So, these are the two methods of prime factorization of numbers. Now, let us see what is HCF and LCM. HCF is highest common factor. So, what is highest common factor? The highest common factor or HCF of two or more given numbers is the highest of their common factors. So, let us see this. So, what is the HCF of 24 and 36? For this, we can write the factors of 24, isn't it? What are the factors of 24? 1, 2, 3, 4, 6, 8, 12 and 24. And what are the factors of 36? They are 1, 2, 3, 4, 6, 9, 12, 18 and 36. And among them, what are the common factors? The common factors are these, they are 1, 2, 3, 4, 6 and 12. And out of these common factors, which is the highest or the greatest? This is 12, 12 is the greatest one. So, the greatest common factor or the highest common factor of 24 and 36 is 12. Now, let us see what is LCM or lowest common multiple. The lowest common multiple of two or more given numbers is the lowest of their common multiples. Okay. So, let us see lowest common multiple of 4 and 8. For this we write multiples of 4. What are they? The multiples of 4 are 4, 8, 12, 16, 20, 24, 28, 32, 36 and so on. And what will be the multiples of 8? They are 8, 16, 24, 32, 40, 48 and so on. Okay. And among them, what are the common multiples? What are the common multiples of 4 and 8? They are 8 and 16, 8 and 16 and 24 and 32, isn't it? And among them, which is the lowest one? The lowest one is 8, isn't it? The common multiples are these and the lowest one is 8. So, the lowest common multiple of 4 and 8 is 8, isn't it? It is not 16, it is 8. Now let us learn some interesting facts about the HCF and LCM. HCF of two co-prime numbers is always 1. Okay. Then HCF of two numbers is always less than or equal to the smaller number. And the HCF of two consecutive numbers is 1. LCM of two co-prime numbers is equal to the product of two numbers. Okay. We have found this out by solving some of the problems also, isn't it? Then LCM of two numbers is always greater than or equal to the larger number. Third one, LCM of two numbers is always greater or equal to the larger number, greater than or equal to the larger number. Now, we have some homework for you. There are a few problems which we left out during the chapter. So, these problems you have to do as homework. Okay. So, you have the homework here, 3 problems are there, you have to solve them. First one, find the smallest 4-digit number which is divisible by 18, 24 and 32. We have done same kind of problem during our exercise. Okay. Then find the LCM of the following numbers and observe a common property in the obtained LCMs. And third one, find the LCM of the following numbers where one number is the factor of the other and find out a common property among them. So, this is the homework for you today. Thank you.